Okay, so what was the one you wanted to see? So this was 7.2?
Yeah, on page 559.
Which number?
Number 42.
42?
Right.
Okay, so what do they ask?
Quadratic equation in X that has a given solution. A is negative 3/5.
Hang on a sec. So give a quadratic equation in X with given solutions. Okay, what are the solutions?
Negative 3/5
Your camera has no color.
and 3/5.
Okay, so I'm supposed to come up with a quadratic equation in X's with the given solutions, right? Okay, and then they gave me two solutions. So what this means graphically, right, is here's negative 3/5, here's 3/5, right? These are supposed to be the zeros of a quadratic, which means,
Yes, they are supposed to be over there.
right, they're supposed to be the solutions of a quadratic, right? So I'm assuming that my quadratic equation is all going to be on the left-hand side. So I'm looking for something like ax squared plus bx plus c equals 0. This isn't the only way to do this, but this is maybe a reasonable way to do this. So what I'm thinking is, okay, on this left-hand side, right, all of this stuff, I think about that as a parabola, right? Pointed up or down. Yeah, sure. This one's pointed up. Really, I'm kind of assuming A is positive. There's no reason for that. You could assume A is negative, it'll give you the same thing. So I'm kind of looking for this U shape, right? You guys see that? Okay, so there are a couple ways to do this. One is I could try to reverse engineer this out of the quadratic formula. This would maybe work. We could do that. You guys want to try that one?
Yeah.
Okay, so let's try that one. So x is negative b plus or minus the square root of what? B squared minus 4ac all over 2a, right? Okay, and I'm supposed to get out of this minus 3/5 and plus 3/5, right? Okay, so this is supposed to be plus minus 3 over 5, right? Okay, so what can I tell already?
That you can deal with perfect squares.
Yeah, that I kind of don't need something here.
The square root and the square.
Yeah, so let's see. I've got this, this square root comes out to 3, really, right? You guys see that? I'm just kind of playing matching. Right, so the 2a here and the 5, those probably go together. And then this stuff in here and the 3 probably go together, right? You guys see that? This is maybe more complicated than I would like. I would like 2a to obviously go with 5. So let me do this. So if I did that, what did I need to do to the top?
Turn it into a 6.
I need to turn that into a 6. You're confused, right?
Oh, yeah.
Okay. So
So top equals 6.
they told me, right, that the x's were supposed to be this. Okay? Now I know that x's for solving things like this come out of the quadratic formula. Right? So things like this and this guy should be the same. I get some choices, right? I get to play with A, B, and C. So I'm looking at this and I'm just saying, okay, the bit after the plus or minus should be the same thing. That's the bit after the plus or minus over here. You see that? So the bit after the plus or minus over here is 3. So maybe that's what comes out of the square root over here. Now, I wanted the bottom to be 2a, right? But 5 is an inconvenient 2a. So I unreduced my fraction so that the bottom would be a more convenient 2a. You guys see that? So out of this, I can know something. What can I know? Yeah, a's got to be 5. That's an assumption I'm making, right? I could unreduce this to a different, I could kind of unreduce this a different way, and then a would be something else. You see that? There are a lot of U-shapes that go through those, right? There's another one that looks like this. You see that? That's a change in what a is, really. It's actually a change in lots of stuff, but primarily it's going to be thought of as a change in a. So here's one choice of a that'll work. Now, what about b? What's the stuff before the plus or minus?
Negative b.
And negative b on this side. What's the stuff before the plus or minus over there?
0.
0, right? There's nothing before the plus or minus. So I know that negative b has to be 0. So what's b?
0.
Negative 0 is 0 still, right? That was our discussion about positive and negative earlier. Okay. So now what about this stuff? This is the bit that's going to be hard. So I want this stuff to be 6, right? So the square root of b squared minus 4ac should be 6.
So you can take the b out, can't you? Because it's 0 already.
Oh yeah, I know what b is. B is 0.
So you'd have to.
Actually, I can do one better, right? A is 5. You see that? So I get the square root of negative 20c is 6. How do I solve this? You guys can do this.
Couldn't you just
Okay?
square 6?
You do 5 times 4.
We
Square
should
6.
square 6, right? This is an extraction of roots problem, right? You guys see that? So I square 6, I get negative 20c is, oh, sorry, this is a reverse of square extraction of roots. So we square both sides. We get negative 20c is 36.
Divide by negative 20.
Then we divide by negative 20, so we get c is 36 over minus 20. Which is kind of a horrible fraction, but it's a fraction, right? So we can simplify. What can we factor out of top and bottom? A 4, right? The top is 4 times 9, and the bottom is
4 times negative 5.
4 times negative 5. So I get negative 9/5.
That's what it said.
You guys with me? This is a horrible number still, right? Yeah, and that's okay. Because all I needed was to write down this equation. So let me just write down the equation. It comes out of a is 5, b is 0, and negative 9/5 for c. Put into the form for the quadratic formula, right? So 5x squared plus
Negative 7 this.
0x, right? Yeah. And that's supposed to be a 9. So minus 9/5 equals 0. Okay, you want to see the easier way?
Yeah, please.
Okay, so the easier way is instead of trying to use the quadratic formula, use the zero product rule. No. So the zero product rule says that a product is 0, right? if one of the items, one of the factors is 0. So my alternative way here would be to do, or, okay, if I want something with a solution of 3/5, x equals 3/5 has that solution, right? If I want something for the solution x is minus 3/5, x is minus 3/5 has that solution. You see this? These are kind of the dumbest thing you could write down, right? These are lines, right? And they're even really dumb lines. So, let me think. If I move things to the other side, I'll get x minus 3/5 equals 0, and x plus 3/5 is 0. You guys see these are the same thing? Okay, now I want to make it quadratic. Well, the easiest way for me to make it quadratic is just multiply some stuff together. So I'm going to multiply x minus 3/5 times x plus 3/5. Now this is a quadratic, right? And if I want it to be an equation, I need a right-hand side. I'm going to use this one so that the zero product rule applies and everything goes that way. You guys see that? This is me reverse engineering the zero product rule. I want a solution, so I make a factor that I can set equal to 0 and get that solution out. I make another factor with the other one that I can set equal to 0 and get the solution out. Then I take my two factors and multiply them together. Set it equal to 0 so I can apply the zero product rule. You guys see that? If you multiply this out and maybe fiddle around with a common bottom here, you'll get that. These are the same thing. So the other solution here is this guy. Yeah, that's all you're right. All I asked for was a quadratic with a quadratic equation in x with given solutions. Here are two. You see that? Okay. Other things? Which one of these ways is easier? The one on the right seems a lot easier, right? But you have to remember the zero product rule and you have to reverse engineer it a bit, right? This is just write down the quadratic formula and solve for the pieces. This is the thing that's procedurally actually easier. This is conceptually a little harder, but is procedurally better, right?
It's quicker.
It's quicker, yeah. But you have to understand the zero product rule and how it works, which is, I don't know, maybe tougher. Okay, other things? Let's see. Okay, we need a quiz and to talk about 9.1. So let's talk about 9.1 for a